Hello, good day. Before we begin or discuss on our next topic about the curvilinear motions, let's review these important formulas from our previous discussions. So last time, in our previous modules, we already discussed about this kinematic equation. So these are equations nga atong gigamit for both the rectilinear kinematics and then the projectile motion. So if you remember, naatay duha ka set of equation. If the equation is if the given problem has a constant acceleration, so we use these formulas. If the acceleration is not constant, so we use these second formulas. For the rectilinear kinematics, if you remember, we have the final velocity is just equal to the initial velocity plus or minus the acceleration times the time. So, mo ni siya ang iyang legend ani. So, last time we used VO or V naught. So, that is just the initial velocity. Lahat lang siya og notations or symbols nga itong gigamit. And then here we use S that was in rectilinear. No, S denotes the position. So, the SF or just the S denotes the final position. And then the S sub I is the initial position. Or the S naught atong previous example. Now, niabot ato sa projectile motion. So, sa projectile motion, the particle is moving along a parabolic motion. So, and then, it is influenced with gravity na, no? So, in this first equation, we only determine or use this for katong straight line lang yung movement. But this one, it duha ka components no ato ang gi-consider. So, natay x component and the y component. It is because since ang particle is moving along a parabolic in a parabolic way in motion, it has a horizontal velocity. If you remember, we use the denote the v sub x or the horizontal or the velocity along the x component, and then also the v sub y. So to get the velocity, if you remember, the velocity is always tangent. So the velocity is always tangent to the motion of the projectile. So this is the velocity. And we know that the velocity is just equal to the square root of v x the x component of the velocity, the square of the x component of the velocity, plus the square of the y component of the velocity. So if the given problem is not having a constant acceleration, it means that ang acceleration sa usa ka particle is ga decelerate, muhinay or mokusog as time goes by, then we use this non-constant acceleration formula. So we know that our acceleration is just the derivative of the velocity with respect to time, and that we know that the velocity is just the derivative of the position with respect to time, or we can use dy over dt as in our future discussions. And also we have this relationship. So we derive this equation katong gi-equate nato ang time sa duha. So we have this, the velocity, the v dv is just equal to the acceleration and then the derivative of the position. So the velocity times the derivative of the velocity is just equal to the acceleration times the derivative of the position.